So this lecture video is about activity 3.3, and the example that we're going to go through is how fast did you lose? Um, and so we have a membership we're a member of a health and fitness club. The club's registered dietitian and your personal trainer helped you develop a special 8-week diet and exercise program. The data in the following table represents your weight W as a function of time T over an 8-week period. So in the first row of this table, I have the time in weeks. So 0 represents right before I start the diet, my weight was 140, and then at the end of week 1, my weight was 136, at the end of week 2, 133, and at the end of week 3, I was at 131 pounds, and so on through the table. So the first thing that we want to do is we want to plot these data points on our graph. And we want to plot them in the form TW, so T is going to go on the x-axis, and W will go on the y-axis. So for an example, we have 131 is one of the data points. That represents our weight at the end of the 3rd week. So first, let's count our tick marks. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm just going to let each one of these be 1 week. And I'm only going to label every other, though. So that would be 2, 4, 6, 8. My axis is time, and it's in weeks. And then weight is going to go on the y-axis, and this is in pounds. And if we go back up to our table, my weight at my top weight I'm 140, and then you see we are going down, and the lowest that I ever get to is 126. So in order to figure out how to scale my y-axis, I want to take my largest weight, 140, and subtract from that 126. And when I do that subtraction, 140 divided by 140 minus 126, I get 14. And there's one thing that we can do that I don't know if we've talked about yet, but if you put these two lines like this, it means that you're cutting a little piece of your y-axis out. And so usually this would be 0 down here, and but then we're cutting this piece out, and so we can start this at any value we want. And so we're going to start that at our lowest weight, which was 126. And we only need 14 units, and we have 1, 2, 3, 4, 5, 6, 7, 8 to do it in. And so if I let every tick mark be worth 2 pounds, then I'll have enough room for all of my weight on there. So this would be 128, so this one would be 130, and then 132, 134, 136, 138, and then this one would be 140. Okay, so now I'm ready to start plotting some points. My first data point is 0, 140. So that point would be right there, and make sure that you label your data points as you plot them. And then my next data point was 136. So 136 would be right here. And the next data point is 2, 133. So that's going to be, so this is 132, so 133 is going to be right in the middle here. And I'm at time t equals 3. So that's going to be 2. 133. And then we have 3, 131. So that'll be right there. And then we have 4, 130. And then we have 5, 127. And then we had 6, 127 was the next data point. And then at week 7, my weight was 130. And then at week 8, I'm down to 126. So there are all of our data points plotted on our graph. What is the practical domain? So practical means what are, the numbers that are practical and possible in this. And so practically speaking, we wouldn't really want to consider negative time. It would be pre-diet would be 0, and then after we started dieting would be weeks 1, 2, 3, 4, and so on. So I would say that a practical domain would be the numbers 0, and then 1, 2, 3, and you could really continue on this diet indefinitely. And what's the practical range of this function? So again, I don't know what the lower amount is. It would really kind of depend on how tall you were you male or female? And so we'll just say that you're short and you're female, and so 100 pounds is the least you might weigh. And then this could go on up to, who knows how heavy you could possibly get at some point, but that number, we really can't put a number on that. So we'll look more at domains and ranges of actual graphs later on, so that will be more useful for you. What is your weight at the beginning of the program? Well, our weight at time t equals 0 was 140 pounds. And so you can either get that from the table or your graph. So we have this data point at 0, 140, or we could get it right out of the table here, either way. And what's your weight at the end of the first week? And so again, we could get it from our graph. We have the point 1, 136, or you could get it out of the table. And so at the end of week 1, my weight was 136 pounds. Now, in order to figure out whether this program is working, we want to analyze the weekly weight changes during the 8-week period, and during which weeks does your weight increase. Let's go back up to our graph. So our weight goes down here, and then it's going down still, and it's going down, and then it stays the same, and then it goes up. So this is the end of week 7. My weight went up to 130, and so it was during week 7 that I gained weight. And during which weeks does your weight decrease? Well, during the first week I lost 4 pounds, and then I lost second week, third week, fourth week, fifth week. I did not lose the 6th week. I remained the same, and I didn't lose the 7th week. I went up, but then I went down in week 8. So that was 1, 2, 3, 4, 5, and 8. During which week does your weight remain unchanged? And so at the end of week 6, I'm still at 127 where I was at the end of week 5. So it was during week 6 that I didn't lose any weight. I remained the same. Now we're going to look at average rate of change. And so this is not how much did I lose actually in a week, it's how much did I lose on average. So we're going to look at more than a week, but figure out an average of our weekly weight loss. And so first we're going to determine the actual change in our weight, the output value, over the first 5 weeks of the program by subtracting your initial weight from the weight at the end of the first 5 weeks. So our initial weight was 140, and I want to subtract from that my weight at the end of the first 5 weeks. And at the end of week 5, I was at 127 pounds. And so that's 13 pounds. And what's the sign of this? Well, it's positive. And what's the significance of the sign? And it means that we lost weight. Now we want to determine the change in the input value over the first 5 weeks, that is from t equals 0 to t equals 5. And just be careful on this. We did our initial weight minus our final weight at the end of week 5, and so you just want to make sure that you subtract the t's in the same order. So the initial t value is 0, and the final was 5. So that would be 0 minus 5 or negative 5. Now we want to write the quotient of the change in weight from part A divided by the change in time in part C and interpret the meaning. And so that would be our 13 pounds divided by negative 5, and that's time. And if we actually do this division, then we would have 13 divided by negative 5, and that gives us negative 2.6. And this is pounds per week. And what is the meaning of this? The meaning of this is that on average, we lost 2.6 pounds per week. Now in this box, we go over the definition of the average rate of change. The average rate of change is equal to the change in the output divided by the change in the input. Again, the one thing that you have to be careful of is that when you do this subtraction to calculate this change, you just subtract in the same order. And so this is y2 minus y1 over x2 minus x1. And this notation, they actually go over a little right after the box, but it's called delta notation. And so this triangle is read delta, so delta y divided by delta x, and it really just means change in this triangle. So this would be read the change in y divided by the change in x. So here it's telling you that the change in output is calculated by subtracting the first or initial output from the second or final, and the change in input is calculated by subtracting the first or initial from the final. And again, as long as you do both of these subtractions in the same order, it doesn't matter which way you do them. You just need to make sure that if you do initial minus final, that you do initial minus final for both of them. So now use delta notation to determine the average rate of change of weight over the last 4 weeks of the program. So we want the change in y divided by the change in x, or y2 minus y1 over x2 minus x1. And so again, it doesn't really matter what order we do this in, but we want the last 4 weeks. And so that will be from t equals 4 to t equals 8. So that was 4 130 and 8 126. So I just want to have those written down so I don't have to scroll back up and check. And so, again, it doesn't matter what order you do your subtraction in as long as you're consistent. So we're going to do y2 minus y1. So that will be 126 minus 130. And then divide that by the change in our x values. And again, just make sure that you do your subtraction in the same order. So I did this bottom number minus the top number, so you need to do the x's in the same way. So do 8 minus 4. And 126 minus 130 gives us a negative 4. And 8 minus 4 gives us 4. And so we get negative 1. Again, it doesn't matter what order we do this in. Again, I'll do the calculation again, only I'll subtract in the opposite order. So if I did 130 minus 126 on the top, then I would just have to make sure that when I subtracted the x values that I did it in the same order. So I'd have to do 4 minus 8. And we'll get the same result. It's just that now the top number will be positive 4 and the bottom number will be negative 4, but we still get negative 1 as our rate of change. And our units on this would be pounds per week. And same here. On the graph in problem 1, we want to connect the points 0, 1, 40 and 5, 1, 27. So let's go up there and do that. And I'll do this in red. So here's 0, 1, 40. And my mind forgets too quickly. And that was 5, 1, 27. Alright, so I want to connect these two that I have circled, and I'll try to draw the best straight line I can, which isn't always all that great. So there we go. There's our line. And does the line segment rise, fall, or remain horizontal as you follow it from left to right? So if we scroll back up to this graph, when we look at this red line segment as we go off from left to right, this is falling. And recall that the average rate of change over the first 5 weeks was negative 2.6 pounds per week. What does the average rate of change tell you about the line segment drawn in part A? So because this average rate of change is negative, it tells me that the line segment should be falling. And it also indicates weight loss. It means we lost weight. Determine the average rate of change of your weight over the time period t equals 5 to 7. And so I'm just going to write those data points down. Let me fix that 5. And I just want to do this so I don't have to keep scrolling back and forth. So at the end of weeks 5 and 7, our weight was 127 and 130. And so we're calculating the average rate of change. So again, average rate of change, I'm just going to abbreviate that as ARC. So this is y2 minus y1 over x2 minus x1. And so we're going to take 130 minus 127. And because I started with the bottom number minus the top number for my numerator, I just need to make sure that I do the same thing in my denominator. So I'm going to take 7 minus 5. And 130 minus 127 is 3. And 7 minus 5 is 2. And so we get 1.5. Interpret the rate in part A with respect to your diet. So we had an average weight gain this time because we had a positive average rate of change. Of 1.5 pounds per week. On the graph in problem 1, we want to connect these 2 points now, and we'll do that in another color. So we did this connection in red, and so we'll do this other connection in blue. And the one that we're doing now is from 5 to 7. So here's week 5, and here's week 7. And so you see our line segment is going up as we move to the right this time, and again that's going to indicate a weight gain. Okay, so we connected those in blue, and this rises. How is the average rate of change of weight over the given 2-week period related to the line segment you drew? And so a positive 1.5, this really means that the line segment rises. And it indicates a weight gain. At what average rate is your weight changing during the 6th week of your diet? That is from t equals 5 to t equals 6. I'm going to change that back to black. So I'm just going to go up and peek at my numbers again. Okay, so here's the data point for 5, and here's the data point for 6, and they're both 127. So our average rate of change is equal to y2 minus y1 over x2 minus x1. So in our numerator, we're going to take 127 minus 127. And in the denominator, we're going to take 6 minus 5. And so that gives us 0 divided by 1. And remember, 0 divided by anything is 0. And so we get 0 pounds per week. Interpret the rate in part A with respect to your diet. So what this means is that our weight stayed the same. Connect the data points 5, 127 and 6, 127. So we did the last one in blue, we'll do this one in green. Okay, so let's go back up and connect those two. So there's the 5, 127, and there's the 6, 127, and now this doesn't rise or fall, it remains the same. So it remains horizontal. How is the average rate of change in part A related to the line segment drawn in part C? So an average rate of change of 0 would indicate a horizontal line segment. Oops. Also means that our weight didn't change. And what is the average rate of change of your weight over the period from t equals 4 to t equals 7 weeks? So I'm going to go up and get those points. So at the end of week 4 I was at 130, and at the end of week 7 I was at 130. And we're calculating the average rate of change, so that's y2 minus y1 over x2 minus x1. Again, I'm going to do bottom minus top. So 130 minus 130. And then just make sure that we do our subtraction in the same order, so 7 minus 4. And that's 0 divided by 3, which is 0. Explain how the rate in Part A reflects the progress of your diet over those 3 weeks, and what it means is that our weight was not changing. Okay, so that is it for this lecture. Let me know if you have any questions. Thanks.